Hi, hello friends. Welcome to T Academy. Let's continue the previous assistant engineer electrical question paper. Now the subject which I am discussing here is analog electronics. So analog electronics, the first question here it is. The question it is assuming the diodes in the circuit to be ideal, the I and V in the circuit are respectively. So here we need to find the values of voltage and current. So here in the given circuit there are a 9 volts source here, and here we have 5 volts, and it is a grounded here like this, and we need to find the current and voltages here. So simply if you are assuming this, observe the circuit here. So its circuit is a balanced circuit here if you are going in terms of bridges, but this is not a bridge circuit here. So simply if we redraw the circuit here like this, so there is a 9 volt source in the resistance like this. So here we have a 9 volt source on the left side circuit here, so 9 volts, and this will be what, 10k 10k. Okay, so this is a point here, and here we have a diode connected like this. Okay, and there is to the right side of the circuit here there is another resistor like this. There is another resistor of 10k and a 10k. Okay, here, and this is a 5 volt source here. Observe the circuit here. Now the current flowing here. So simply by looking at the question itself, does the current will flow? Current will not flow, because if there is a connection between this circuit and this circuit, then there will be a current here. Now okay, we'll check that. Okay, so whatever I am saying here is theoretically here. Well, let's check this one is a practically here. So assume the anode here and a cathode here. Okay, these are the 2 points. Now if you apply the voltage division rule here, okay, to find the value of Vk. So Vk is nothing but the total voltage 9 into opposite resistance divided by total resistance. So I'm applying the voltage division rule here. It is nothing but 4.5 volts here. And what about the anode? Same concept here. It is a 5 into 10k divided by 20k. So I'm applying the voltage division rule. Voltage division rule here. Okay, so based on this concept it's a 2.5 volts here. Now what is a VAK? So in order to current flow, the VAK value should be greater than 0 if it's an ideal one, or practical one means it should be greater than 0.7 volts. But the diode will not connect if the VAK value is negative. Now VA minus VK is equal to, what's the VA value it is? Okay, so we need to find the value of VAK. So VA minus VK here. What is the VA value? So anode value is here. So it is 2.5 minus 4.5. It is nothing but minus 2 volts here. So the diode will not conduct, and the VAK will be negative, current will be 0. Why? Because diode is in reverse bias condition, the current will not be 0 here. So hence it is proved that the reverse bias diode will not conduct, and the voltage across it is negative. So answer is C. Answer is first they are asking current, then it is voltage. So current means it is 0 amperes, voltage means minus 2 volts here. So answer will be C here. Let's move to the next question here. Okay, all right, this question here. The number of comparators required to design a 4-bit flash ADC converter, that is a analog to digital converter here. Okay, so you know the formula, simple formula here, that is a 2 power n minus 1. Okay, so the number of comparators required to design a n-bit flash ADC is, which is equal to 2 power n minus 1. That implies there are 4 bits. 2 power 4 minus 1, that is nothing but 16 minus 1, which is equal to 15. Okay, 15 comparators are required here. Next question here from the analog and digital electronics, analog electronics here. Now this question is from the analog electronics. The highest frequency of a triangular wave of 20 volts peak to peak amplitude that can be reproduced by an op amp whose slew rate is 10 volts per microseconds will be. Okay, so here so we are talking about this triangular wave here. So let me draw the triangular wave here like this. It is like this. Okay, now what's the time period starting from here? Okay, 1 and up to here. So it's going to complete the one half cycle up to this point here. So this is the point here. So this will be our time period. Now 20 volts peak to peak amplitude means, so 20 volts divided by, it's going to cover in how many, it's going to be a half cycle here. Okay, half cycle. So it is a 10 volts positive, okay, 10 volts negative. So both are going to be 20 together. So 20, and it is going to cover in a time period of 20 t by 2. So this is nothing but a sleeve rate. What is sleeve rate? They given 10 volts per microseconds. So substitute these values. T is going to be 4 microseconds, and if in terms of frequency, f is nothing but 1 by t, which is equal to 250 kilohertz. So answer will be C is 250 kilohertz here. And the next question asked in this paper regarding op amp here. Okay, so what is this? For the open loop, for open amp, there is an operation amplifier circuit shown with a square wave input. Okay, square wave input, the output form will be, so here the given it is a square wave input like this. Okay, what will be the output? So just you need to identify the circuit here, whether it is integrator or a differentiator. If you observe the circuit here, say it acts as a differentiator. So differentiator. Now simply you are going to differentiate this square wave, then you are going to get the spikes here. So answer will be B is the right answer for this question here. Why? Because the circuit acts as a differentiator circuit. Okay, so next question of this video. Right. Okay, right, this question here. The input voltage to the non-inverting op amp, the operational amplifier is Vs is equal to 10 sin 2000 t. The source resistance Rs is negligible if the feedback resistance is 20 kilo ohms and the R1 value is a 5 kilo ohm, Vcc is 15 volts and the VE is minus 15. The peak voltages of the output voltages are. So here the given question is about the non-inverting amplifier. Okay, so for the non-inverting amplifier, the peak value of its output voltage will be V saturation is equal to, it is simply VCC only. That is the maximum value will be 15 and minus 15 only. Okay, so answer will be 15 minus 15 here. Okay, next question here in this paper is the diode circuit shown in the figure R is equal to 30 kilo ohms. Here it is given as a 30 kilo ohms and VDD is nothing but 10 volts here. So plus 10 volts and Vs is 5 volts. So what is Vs? So here it is Vg. Sorry. Okay, Vs, this one is, it is a 5 volts here. Okay, plus 5 volts and the voltage drop Vd is 0.7 volts. That means voltage drop across each and every diode will be 0.7 volts here. Then V0 will be, where is the V0? Here is the V0. Here we need to find the V0 here. If the voltage is given as 0.7 volts, just apply here equivalent voltage source model. Here it is like this. So 0.7, 0.7, 0.7. So V0 will be equal to what? V0 will be equal to 2.1 volts. Let's check here. So here the voltage will be 2.1 volts and the remaining voltage is going to appear across here. It is a 7.9 volts will be appear here. Now it's a 2.1 volts. See, check whether this D3 and D4 are in on condition or off condition. So here we have 5 volts at the cathode and it is like this. Sorry, let me redraw the circuit here. Okay, it is like this and here we have 2.1 volts. Now see here the VAK should be positive. So VA minus, let me correct here, VA minus VK, 2.1 minus 5, it is minus 2.9 volts here. That's wrong. That means negative means this diode D4 and D3 is in off condition. Okay, so D3 and D4 is in off condition. So V0 will be equal to, it is 2.1 volts. So by directly looking at the question itself we can answer. And next question, consider the following statements. So BJT is a current control device and IGBT is a voltage control device. So first option, we know that BJT is a current control device, and whereas IGBT and MOSFET are voltage control devices. So first option is correct. Next one, the BJT and IGBT have low input impedance, whereas P MOSFET has higher input impedance. So see here, the BJT will have the low input impedance, and IGBT, okay, IGBT will have high input impedance. So this will have high input impedance. So second statement is a wrong statement. Next one, IGBTs are available at higher voltage ratings than the power MOSFETs because the increment in the on state voltage drop is less in IGBT. So this statement is correct here. And IGBTs and P MOSFETs have different substrate levels. That means they have P plus, N minus, different substrate levels are there. So this one also correct. So among this all the options, the second option is wrong and the first 1, 3, 4 options are correct. So the correct answer for this question is, it's a B. And the last question for this session, okay. The rise time TR in a BJT is defined as the time during which the collector current rises from, okay. So the collector current rises from, that means the rise time they are asking about. The rise time is nothing but it is a time required for the collector current in a BJT to rise from 10%. So 10% of its saturation current to 90% of its maximum saturation current. That is a 0.12 ICS to 0.9 ICS value. So D will be the right answer for this question. So that's it for this session, friends. We will continue this AE previous year question papers in the next upcoming videos. Thank you. Have a nice day. If you like this video, please share with your friends and subscribe to the channel so that it will motivate us to do more and more videos for you. And all the best for your preparation. Thank you.